Hello and welcome to this exemplified read-through of Datetime module of Python Standard Library. We had covered till TZ-info objects and we will try to finish this module in this video. Not much is remaining. So lots of examples are given for this module. That is why I'm not crafting any other examples for this module. So without further ado, let's get started. So the name of the class is TZ-info. This is an abstract base class, meaning that this class should not be instantiated directly. Define a subclass of TZ-info to capture information about a particular time zone. An instance of a concrete subclass of TZ-info can be passed to the constructors for date time and time objects. You have seen one Kabul TZ, right? I believe Kabul TZ we have seen. Okay, we have TZ1. So this is how you implement a subclass. We'll further see this, how this works. The latter objects view their attributes as being in local time, and the TZ-info object supports methods revealing offset of local time from UTC, the name of the time zone, and DST offset, all relative to a date or time object passed to them. You need to derive a concrete subclass and at least supply implementation of the standard TZ-info methods needed by the datetime methods you use. The datetime module provides time zone, a simple concrete subclass of TZ-info, which can represent time zones with fixed offset UTC such as UTC itself or North American EST and EET. So we have a time zone class which we can use, objects of time zone. Special requirements for pickling. A TZ-info subclass must have an init method that can be called with no arguments. Otherwise, it can be pickled but possibly not unpickled again. This is a technical requirement that may be relaxed in the future. A concrete subclass of TZ-info may need to implement the following methods. Exactly which methods are needed depends on the usage made of our datetime objects. If in doubt, simply implement all of them. So we need to implement the UTC offset. It takes an argument UT. Return offset of local time from UTC as a time delta object, that is a positive east of UTC. If local time is west of UTC, this should be negative. This represents the local offset from UTC. For example, if a TZ-info object represents both time zone and DST adjustments, UTC offset should return their sum. If the UTC offset isn't well known, return none. Else, the value returned must be a time delta object strictly between minus time delta hours is equal to 24 and time delta hours is equal to 24. The magnitude of the offset must be less than 1 day. Most implementation of UTC offset will probably look like one of these two: return constant plus self.dst. If UTC offset does not return none, DST should not return none either. The default implementation of UTC offset page is not implemented error. The second function which we need to implement is DST. Return the date time saving time DST adjustment as a time delta object or none if DST information isn't known. Return time delta 0 if DST is not in effect. If DST is in effect, return the offset as a time delta object. Note that DST offset, if applicable, has already been added to the UTC offset returned by the UTC offset. So there is no need to consult DST unless you are interested in obtaining DST info separately. For example, datetime.time tuple calls its TZ-info attributes DST method to determine how the TM underscore is DST flag should be set, and TZ-info.from UTC calls DST to account for DST changes when crossing time zone. An instance TZ of TZ-info subclass that models both standard and daylight time must be consistent in this sense. So tz.utc offset minus tz.dst should have that. Must return the same result for every date time dt with dt.tzinfo is equal to tz. For same tzinfo subclasses, this expression yields the time zone's standard offset, which should not depend on the date or the time, but only on geographic location. The implementation of datetime.as time zone relies on this, but cannot detect violations. It is the programmer's responsibility to ensure it. If a tzinfo subclass cannot guarantee this, it may be able to override the default implementation of tzinfo.fromUtc to work correctly with as time zone regardless. Most implementation of DST will probably look like one of these two. So we have DST function here, it returns a time delta 0, it does not account for DST. Then the second example is when time zone tz is equal to none is replaced and DST on is less than equal to this and which is less than DST off, then it returns time delta hours is equal to 1, otherwise it returns time delta 0. The default implementation of DST raises not implemented error. The third function which we need to implement is return the time zone is tz name. Return the time zone name corresponding to the date time object dt as a string. Nothing about string names is defined by the datetime module, and there is no requirement that it mean anything in particular. For example, GMT UTC -5 colon 00 EDT and so on are all valid replies. Return none if a string name isn't known. Note that this is a method rather than a fixed string family because some tzinfo subclasses will wish to return different names depending on the specific value of dt passed, especially if the tzinfo class is accounting for daylight time. The default implementation of tz name is not implemented error. So you see, these are the three functions which we need to implement, and those were implemented here. Okay, so UTC offset was 1 hour, DST was off, and tz name was 1. So these requirements you have to fulfill when you create a child class of tzinfo. Okay, so we were here. These methods are called by a datetime or time object in response to their methods of the same names. A datetime object passes itself as the argument, and a time object passes none as the argument. A tzinfo subclass's method should therefore be prepared to accept a dt argument of none or of class datetime. When none is passed, it is up to the class designer to decide the best response. For example, returning none is appropriate if the class wishes to say that time objects don't participate in the tzinfo protocols. It may be more useful for UTC offset none to return the standard UTC offset, as there is no other convention for discovering the standard offset. When a datetime object is passed in response to a datetime method, dt.tzinfo is the same object as self. tzinfo methods can rely on this unless user code calls tzinfo method directly. The intent is that the tzinfo method interpret dt as being in local time and not need to worry about objects in other time zones. There is one more tzinfo method that a subclass may wish to override, that is from UTC function. This is called from the default datetime.as time zone implementation. When called from that, dt.tzinfo itself and dt's date and time delta are to be viewed as expressing the UTC time. The purpose of from UTC is to adjust the date and time data, returning an equivalent date time in self's local time. Most tzinfo subclasses should be able to inherit the default from UTC implementation without problems. It is strong enough to handle fixed offset time zones and time zones accounting for both standard and daylight time, and the latter even if the DST transition times differ in different years. An example of a time zone The default from UTC implementation when handled correctly in all cases is one where the standard offset from UTC depends on the specific date and time passed, which can happen for political reasons. The default implementations of as time zone and from UTC may not produce the result you want if the result is one of the hours straddling the moment the standard offset changes. Skipping code for error cases, the default from UTC implementation acts like. So we have the from UTC function, it returns the self, that is the date time object or date object. We have dt of when dot UTC offset and dt dst it takes from when. So both it takes from when. And then it computes the delta. If delta, then to when it adds delta, and dst is taken from when again. If dt dst, then it returns when dot dst tangent, else it returns one. In the following tj info underscore examples dot py, there are some examples of tj info classes. So we have date time object, we have time object, we have 0 is equal to time delta 0, hour is equal to 1 hour, and seconds is equal to 1. Standard offset is time delta, seconds minus is equal to time dot time zone. If it is daylight time, then time delta is seconds is equal to alternative zone. And DST offset is STD offset. DST difference is DST offset to standard offset. Then it creates a local time zone and implements all those functions which we studied. So we have from UTC, UTC offset, DST, and period name. So it asserts that period info is self. It computes the second of the timestamp and it computes the arguments and takes the sixth one. So DST difference is then calculated and it detects fold. Fold, if you remember, we had discussed fold earlier. And finally, it returns a date time object. And UTC offset is simply returning offset. DST is returning whether it is 0 or non-zero. And TJ name simply returns the name of one. And if DST is calculated here, so it is a boolean, so it is fairly trivial. And then you can create object of local. And then you invoke this first Sunday on or after, and when you have this date time class, it will internally make use of the local time zone. So you can go ahead and read the example for yourself. It's quite big one. Note that there are unavoidable subtleties twice per year in a TZ info subclass accounting for both standard and daylight time at the DST transition points. For correctness, consider US Eastern UTC-5, where EDT begins the minute after 1:59 on second Sunday in March and ends the minute after 1:59 on the first Sunday in November. We have examples of when the DST changes. When DST starts the start line, the local wall clock leaps from 1:59 to 30. The wall time of the form 2:mm doesn't really make sense on that day. So as time zone, Eastern won't deliver a result with hour is equal to 2 on the day DST begins. For example, at the spring forward transition of 2016, we get this. So after 1, you have got 3, there is no 2. When DST ends the end line, there is a potentially worse problem. There is an hour that can't be spelled unambiguously in local wall time. The last hour of daylight time. In Eastern time, that is times of the form 5 km UTC on the daylight time ends. The local wall clock leaps from 1:59 back to 1 again. Local times of the form 1 km are ambiguous. As time zone mimics the local wall's behavior by mapping two adjacent UTC hours into the same local hour then. In the Eastern example, UTC times of the form 5 km and 6 km both map to 1 km when converted to Eastern. But earlier times have the fold attribute set to 0 and the latter times have it set to 1. For example, at the fallback transition of 2016, So you take a UTC time and you convert it to Eastern time zone, and for two different values, you get the same output. Okay? The difference is this fold. So by looking at fold, you can know what is happening to clock. Note that the datetime instances that differ only by the value of fold attributes are considered equal in comparison. So you cannot specifically say that they are different in comparison. Applications that can't bear well time ambiguity should explicitly check the value of the fold attribute or avoid using hybrid precedence subclasses. There are no ambiguities when using time zone or any other fixed offset precedence subclass, such as the class representing only EST or only EDT. We will see zone info module in the next chapter, next video that is. Then we have time zone objects. The time zone class is a subclass of period info, each instance of which represents a time zone defined by a fixed offset from UTC. Objects of this class cannot be used to represent time zone information in the locations where different offsets are used in different days of the year or where historical changes have been made to civil time. So it's a time zone class, and it receives offset and name. The offset argument must be specified as a time delta object representing the difference between the local time and UTC. It must be strictly between the usual range of time delta, otherwise value error is raised. The name argument is optional. If specified, it must be a string that will be used as a value returned by the datetime.pgetName method. Then we have UTC offset, return the fixed value specified when the time zone instance is constructed. The DT argument is ignored. The return value is a time delta instance equal to the difference between the local time and UTC. Then we have TGetName, return the fixed value specified when the time zone instance is constructed. The name is not provided in the constructor. The name returned by, if name is not provided in the constructor, the name returned by TGetName DT is generated from the value of the offset as follows. If offset is time delta 0, the name is UTC. Otherwise, it is a string in the format UTC plus minus HH colon mm, where plus minus is the sign of offset. HH and mm are two digits of offset.hours and offset.minutes respectively. Then we have DST, always return none. From UTC returns DT plus offset. The DT argument must be an aware datetime instance with TJ info set to self. We have a class attribute which is UTC, the UTC time zone, which returns time zone time delta 0. Now we look at strft time and strp time behavior, the formatting functions. Date time, and time objects all support strft time format method to create a string representing the time under the control of an explicit format string. Conversely, the strp time, strp time, and time.strp time class methods create an object from a string representing the time and corresponding format string. The table below provides a high-level comparison of strft time versus strp time. So they do the reverse thing. One converts object to a string, another converts string to an object. One is an instance method, another is class method. And these are the signatures. So we are given below the code of strft time and strp time. So I will not read this. You can go ahead and read this on your own. It is quite big, and it would be best if you get used to it. These may not be available on all platforms when used with the strft time method. ISO 8601 year and ISO 8601 week directives are not interchangeable with the year and week number directives above. Calling strp time with incomplete or ambiguous ISO 8601 directives will raise a value error. The full set of format code supported across various platforms because Python calls the platform C libraries strft function and platform variables variations are common. To see the full set of format code supported on your platform, consider the strft time 3 documentation. So what it means to say is, you should look at this man 3 strft time. So this is what dictates the format string, and as you can see, it is described in great detail. The codes are all described here. Okay, so you can look at this. This is a C function, and you can go through this. Broadly speaking, d.strft time format acts like the time modules at time.strft time, although not objects support a time call method. For the strp time and wait.strp time class methods, the default value is this, that is beginning of 1900. Any components not specified in the format string will be pulled from the default value. So these are some technical details which I believe we can skip. We can go ahead and read this, or maybe we can cover this. Now we will skip this. You can read this on your own. So two things you need to read, that is the technical detail, and the second is these codes you need to read on your own. So with this, we end this video here, and I'll see you in the next video after 4 days. I hope that you are enjoying the read through and finding it useful for the study of Python standard library. Note that standard library will be used greatly when we do application programming, particularly when we do the REST APIs in Python and we create web applications. So with this, I will end this video here, and we will meet again after 4 days with next video on Zone Info, right? Next is Zone Info. So we will study Zone Info, and it should take one video to complete Zone Info. It's a small module, and I will come up with some practical examples of Zone Info. So keep learning, and I'll take my leave here, and you have a great day today. Enjoy.